Hey everyone, Nathan Zabadil here. Today, I'm going to teach you all about artificial intelligence, also known as AI for short. Today, we are going to start with an introduction to AI, and more specifically, neural networks. First off, let's define artificial intelligence. When you think about AI, you may think about the movies where a robot has the full functions of a human being, becoming sentient, and are the cause for the end of the world. But we are quite a few years away from that reality. Artificial intelligence is a branch of computer science focused on building machines that can perform tasks that usually require human intellect, such as visual perception, speech recognition, decision-making, and translation between languages. Some examples include Siri and Alexa, facial recognition like on your iPhone, and self-driving cars. Now that we understand what AI is, what are neural networks? Neural stands for brain, and such as the name implies, neural networks are algorithms designed to emulate the functions of the brain by taking inspiration from the brain's structure. Neural networks usually boil down to three things: receiving an input, breaking the input down and recognizing patterns, and then producing the output. Here's a look at a neural network structure. These dots connected by these lines are called neurons. Now on the left, we have the inputs we give to the neural network. In the middle, we have the hidden layer, responsible for all the calculations given from the input. And on the right side, we finally have the output, which is derived from the input data. One crucial step after creating a neural network is training the neural network to function properly. How we train a neural network is by feeding the network a large amount of data that is already labeled so the network can understand what is exactly what. To help explain neural networks, let's run through a quick example. This neural network is designed to correctly identify objects in a picture. To start off, the neural network will be fed a large amount of already labeled data, such as pictures of airplanes, birds, trucks, and more, so it can understand what these objects look like. Next, we run a test on the neural network. As you can see on the diagram below, we're inputting the picture of an airplane into the neural network. The network proceeds to break the image of the plane down into smaller parts. The network takes the image and assigns weights to each pixel of the image, which are shown as the little question mark dots on the graph. These weights are sent into the hidden layer. Calculations are then performed on these hidden layers using advanced algorithms to attempt to determine the object being presented. These are the new calculated weights shown on the neurons in the middle layer. Some neurons with a low enough weight value are deactivated if they fail the requirements for what is called the activation function, and the ones that are activated are fed into the final output layer. In the final output layer, we can see three possible predictions for what the neural network thinks the image is. After the numerical weights have gone through the hidden layer, they are then assigned to each of the output neurons. The numbers assigned to the output neurons are the network's probability the object in the input image corresponds to the output neuron. As we can see here, the neuron with the highest probability is the plane, so the neural network will determine the image is a plane, which is the correct option. This whole process is called forward propagation. But what if the neural network makes an incorrect choice? As we can see in the second example, the neural network incorrectly identifies the plane as a bird. Well, when training the neural network and performing tests, we feed the neural network the actual correct output at the end, along with the error of each prediction. The neural network takes the actual output data and errors and makes modifications to the weights within the neural network. These occur incrementally, one at a time, and these modifications are then tested again and again to see if this helps the neural network produce the correct result. This process of going back from the output and modifying the weight values is called backpropagation. After the proper weight modifications have been made, the neural network will correctly identify the image as a plane. Practical uses for processes like this example include image recognition, as shown in this video, facial recognition, such as how you can use your face to unlock your iPhone, and text-to-image recognition, which allows your smartphone to identify text within images and sometimes even translate the text from a foreign language. So here's a quick recap from our examples. First, we train the neural network with labeled input data. Second, we present the unlabeled input image to a neural network. Third, the image is split up into smaller pieces that are analyzed individually, and weights are assigned and calculated in the hidden layer, also known as forward propagation. Fourth, the neural network makes a prediction as to what the image is with probabilities. The network is then presented with the actual output in the training to compare. And fifth, if the prediction is off in training, weights and calculations are modified iteratively throughout the network until it makes the correct prediction, also known as backpropagation. And with that, that will be the end of today's lesson. Hope you all had a great day, and thank you for watching.